Chapter 6, Quality. This chapter will explore quality and total quality management. Topics will include Six Sigma, various quality tools, and quality topics for services. For example, the Arnold Palmer Hospital addresses quality through continuous improvement, empowerment, benchmarking, and other quality tools. Quality initiatives can be a key element of the company's overall strategy. Top quality is necessary to implement differentiation and response process strategies. The result can be increased sales and reduced operating costs. The drive for quality starts at the top and must include the entire organization. Quality improvements result in increased sales through responsiveness, flexibility, and an improved reputation. Improved quality will increase productivity, reduce rework and scrap costs, and lower warranty costs. The combination of increased sales and lower costs will result in net profit increases. Moving an organization toward improved quality starts at the top. The mission of the organization must be in alignment with the improvements. Organizational strategies are then pulled into alignment. Operating procedures follow with the necessary staffing, training, and change management. Appropriate quality principles and associated tools are selected. Quality improvement requires defined plans and the necessary tools. To be successful, quality must be more than a slogan. Once properly trained, employees are empowered to be successful. This must be seen as part of the fabric of the organization, not just the initiative of the week. The ultimate result will be improved customer satisfaction, which will result in increased sales. The needs of the customer form the foundation of your quality efforts. The entire quality framework must be aligned with customer needs. Quality is based on the customer's viewpoint. Products and services are delivered that meet and exceed customer expectations. All actions must directly or indirectly support these goals. Here are some dimensions of quality for a laptop computer. Starting with the customer view, we list the various capabilities of the computer. Note that some requirements are specific to the physical product, while others are related to the services provided in support of the customer experience. These include handoff, help desk, technical support, and repair. From an operations viewpoint, key metrics include cycle time, yield, cost, manufacturability, supplier performance, and logistics. Finally, we consider society's view of the environmental impact of the creation and use of the computer. The broader implications of quality include company reputation, liability, risk, and global impact. Product recalls, as seen in the auto industry, have a negative effect at all levels of quality. Consider the cost and reputation impact on a company. The Malcolm Baldrige National Quality Award was created by the U.S. government in 1988 to encourage U.S. companies to implement improved quality practices. Out of 1,639 applicants since its inception, 102 awards have been granted. This includes 7 organizations who have received the award twice. Some recent recipients are listed here. Note the mix of product and service-based companies. The Baldrige selection criteria are shown here. Note the emphasis on leadership. The judges believe that leadership commitment ensures full implementation and sustainability. In addition, companies that apply will be compared with best-in-class methods to identify gaps. ISO 9000 certification has international recognition, with over 1 million certified companies across 206 countries. Since this is recognized internationally, ISO 9000 certification is critical for a global business. The focus is on procedures, documentation, and record keeping. The goal is to set company standards and ensure that processes match those standards. Some quality managers believe that ISO 9000 is the starting point, while the Baldrige Award is the goal. The ISO 9000 quality standards are listed here. Similar to the Baldrige Award, there is a focus on leadership along with customer satisfaction. These are followed by structured processes and analysis. Employee and supplier engagement are also considered. Earlier, we had mentioned that improved quality can reduce cost. Let's consider the elements of cost of quality. Prevention costs come from steps taken in product and process design to reduce the possibility of defects. Evaluating products and services results in appraisal cost. Appraisal includes various forms of inspection. When a defective part is identified and corrected prior to shipment to the customer, this is considered to be an internal failure cost. Finally, if a defect is found after customer delivery, this results in an external failure cost. When new products are introduced, unfortunately, startup quality costs are high due to infant mortality and learning curve issues. As the product and process mature with the correction of identified issues, yield improves and costs go down. Ethics are important for quality managers as they deal with issues that can have catastrophic effects. Unfortunately, quality goals are often in conflict with cost and delivery goals. No one wants to be the bearer of bad news, but all stakeholders must be considered in any major decision, like a major product recall. Total Quality Management, or TQM, is an all-encompassing method covering all aspects of the operation from supplier to customer. The result is an all-inclusive drive to eliminate defects and improve processes. This is not just a product view, but includes all aspects of the customer experience, including sales, billing, and service. The elements of TQM are listed here. Note that this approach incorporates a number of well-known methods including Six Sigma, benchmarking, just-in-time, and a variety of tools. We don't always consider just-in-time to be a quality-driven approach, but more of an inventory reduction and cycle time improvement method. The quality impact of just-in-time will be discussed to explain its inclusion. Continuous improvement uses small continuous steps to improve processes, to eliminate defects, cut waste, and improve cycle time. The principles of Kaizen are applied to all aspects of the business. Every process should be better tomorrow than it is today. Statistically, Six Sigma is defined as a product or process generating less than 3.4 defects per million opportunities, and includes a program designed to reduce defects, lower costs, and save time to ultimately improve customer satisfaction. This diagram of a normal curve shows the impact of Six Sigma. Designs traditionally used plus or minus 3 sigma. The result can be up to 2,700 defects per million. Moving to Six Sigma makes a huge difference. Six Sigma was created by Bill Smith at Motorola, later to be tailored by other companies for their use. The program includes the DMAIC process along with a specific set of tools. The elements of the DMAIC process are shown here. We start by defining the specific goals and the scope of the project. The process is measured, and then this data is analyzed. Using the analysis, improvements are made to existing designs and processes. Finally, the process is controlled to make sure the changes are maintained. Now the DMAIC process starts again. The steps required to implement Six Sigma are listed here. Upper management support, including designated champions, is an important first step. Extensive training is provided, leading to the qualification of employees to varying belt levels based on their knowledge and demonstrated skill. Reach-out objectives are set, ultimately aiming at 3.4 parts per million defect rates. As stated, deploying Six Sigma is a major long-term undertaking requiring the support of top management. One major tenet of Six Sigma is that improvement comes from process change and not more employee training. In the past, defects were thought to be due to employee error. Six Sigma drives change through improved materials and processes. Employees are seen as an asset to be leveraged. As a result, employee input is sought, and they are empowered to identify opportunities for change. This includes teams of employees working to solve problems and update processes. One method of employee engagement is through quality circles. These are groups of employees working together to solve problems. Extra training and access to experts are usually included. The effort results in improved processes and employee morale. Another method common to Six Sigma is benchmarking. The goal is to identify specific processes within the operation and seek information about the best-in-class methods used elsewhere that may be adopted. The sources for this information may be internal or external. One approach is to seek out companies who are not competitors yet have similar processes. These companies are certainly more open to sharing information than a competitor might be. Surprisingly, just-in-time systems are included in Six Sigma methods. The goal is to establish a pull system where items are produced by need rather than forecast. The result is reduced inventory levels. Processes, products, and operational costs all improve. This graphic depicts an organization with high inventory levels. Excess inventory hides issues with vendors, scrap, and capacity balance. If we have enough inventory, it's smooth sailing. Reducing the inventory reveals the issues within the operation. In this example, vendor issues are identified first. Once the vendor issues are addressed, the inventory can be reduced again, revealing the scrap and then the capacity issues. The methods of Six Sigma can be used to address these quality issues, thus permanently lowering the required inventory, moving closer to a just-in-time model. To achieve a just-in-time process, careful management of the operation is necessary. Any issues with the supply chain can bring the entire operation to a halt. Taguchi principles are applied to product and process design with the goal of uniformity despite variability in the materials and processes. Next, we look at the tools used to support total quality management. These tools are used for brainstorming, data analysis, and identifying problems. Each of these tools will be discussed in further detail. The first tool is the check sheet. This is a tool used to collect data regarding a product or process. This example is a tick sheet capturing defects by type over time. The scatter diagram, our second tool, tracks the value of one variable versus another. Here we see that reduced absenteeism results in increased productivity. The cause and effect diagram is also known as the fishbone or Ishikawa diagram. The tool is used to identify different causes for a given effect. This is often considered to be a tool to facilitate brainstorming. The four primary causes are broken down into materials, methods, manpower, and machinery. You may use different groupings based upon the specific application. Here's an example of a completed cause and effect diagram identifying the causes of missed free throws in basketball. Notice that multiple potential causes have been identified for each major category. Each has been tailored to this example. The next tool is the Pareto chart. This chart organizes problems in decreasing frequency. In this case, issue A is the most frequent, so it starts to the left, followed by the next most frequent issue, B. While not always the case, the 80-20 rule often applies. This means that 20% of the items account for 80% of the frequency. This chart is useful when identifying the critical few versus the trivial many issues. Since resources are typically limited, it is best to focus on repairing those items with the greatest impact. Here's an example of a Pareto chart of complaints at a hotel. We start with room service at the left with 72% of the complaints. If we can resolve the room service issues, we will have a greater impact than if we had resolved all of the other issues. In practice, we would take action to resolve the room service issues. Once fixes have been implemented and the process stabilized, we would collect the data again to identify the next action item. The flowchart or process diagram is used to diagram the steps in a process and their relationship. This tool is useful when reviewing existing processes or designing new processes. The chart identifies dependencies and is the basis for cycle time and capacity analysis. This flowchart reviews the steps in the process of completing an MRI for a patient. Magnetic resonance imaging is used to detect medical issues within patients, such as tumors, certain heart conditions, and orthopedic issues. The process starts with scheduling and patient preparation. After the scan is completed, there is one decision point, the diamond at step 7, where the decision is made as to the quality of the scan. 80% of the time the scan is good and passed on to the radiologist, who reports his results to the patient's physician. The next tool is the histogram. The histogram is a distribution of the frequency of occurrences of a variable. The pattern shown is typical with a distribution that is similar to a normal curve. Given enough data, many processes approach the normal distribution. That is why the normal distribution is used to model so many business processes. The statistical process control chart is used to track actual results for a process, to define when corrective action is needed to keep the process under control, meeting the customer specifications. The upper and lower control limits identify the points where the process will no longer be in control. We use statistical control charts to manage a process. We are looking for out-of-compliance points. Here are the fifth and last data points. We also watch for trends so that proactive corrective action may be taken before defects are created. This data provides the opportunity to improve the process and immediately see the results of our efforts. We continue to monitor the process to ensure compliance and react to future variants as needed. Here's an example of an SPC chart applied to basketball free throws. The metric is the number of missed free throws. Obviously, there is no such thing as too few misses, so the lower control limit is 0. The coaches decided that greater than 40% misses calls for action. This is the last of the Six Sigma tools to be discussed. The next topic is inspection. An employee checks for the function of a product and sets it aside for repair or disposal if not to specification. The inspection itself does not fix the process variation that caused the defect, but it does help us identify when there is an issue that needs correcting. Inspection is expensive and does not always catch all of the defects. Defective products that pass inspection are often called escaping defects. When inspecting, the earlier in the process, the better. If a defect is found at the first process, we have not added value through subsequent processes, so the business impact is minimized. If a purchased component is defective, better to catch the issue at the supplier's facility before it has been shipped to the customer. The next best location is at product receiving. After that, try to catch defects prior to any expensive or irreversible processes. The last place you want to find defects is in the customer's hands. Source control occurs when the product is inspected right after the item is produced. This step ensures that issues are corrected immediately before being exposed to the customer. Source control uses thorough checklists to ensure that specifications are met. Poka-Yoke tools are often used at this stage to stop any defective products. Here are some examples of inspection from the service industry. For a hospital and an airline, we see a sampling of the services provided as part of the overall customer experience. For each inspection, the standards are listed. Accuracy is key in the hospital, while cycle time drives the airline industry. Poka-Yoke is a method to create test fixtures and devices to quickly and accurately check the functionality of a product so that acceptable product moves forward in the process. Examples of failsafing are shown here. Classic go, no-go gauges in the tooling industry are well known. Examples that we see every day include three-pronged electrical plugs. They can only be inserted into an outlet one way, the correct way. USB connectors only go in one way. In the example of Poka-Yoke, the product being tested either passes or fails. This would be an attribute quality measure. There is no degree of failure. Conversely, variable quality measures have dimensions such as weight, speed, and height. We decide if the measurement falls within an acceptable range. In addition, we gain valuable data to analyze the distribution of measurements. Different statistical techniques are used for attributes and variables. Management of quality within a service business can be more difficult, since service quality is often an eye of the beholder issue. The customer's view of product acceptance may have intangible factors that vary from customer to customer. I'll know it when I see it. The service recovery process is designed to address failures and is often customized for each situation and can be very fluid based upon the issue and the customer's response. In this example, the team at Alaska Airlines has a number of performance specifications for the operations. For airlines, an airplane on the ground is not making money. We see that the specifications support an overall goal of getting the airplane ready for takeoff on time to prevent delays. Each has a time element within the measurement. There are many factors that drive the outcomes of a service. To achieve top levels of customer satisfaction, these determinants are often closely managed. Looking at the list, consistency, competence, communication, and understanding are some of the goals. Note that these goals are somewhat intangible and may be difficult to quantify. There are some tangible aspects to consider, but these are only a small part of guaranteeing a positive customer experience. At Marriott's hotels, they've established a specific method of dealing with issues. When a customer has a bad experience, they determine what the issue was and resolve it in a supportive way. It is not enough to fix the problem, the customer must be dealt with in an empathetic way. This slide identifies a number of the key leaders in quality. Collectively, they have defined the methods and tools necessary for total quality management. It is interesting to note that all worked within the United States but were largely ignored. Japanese companies, especially Toyota, adopted their techniques to drive quality innovation starting with the auto industry. It is only after Japanese cars outperformed U.S. cars that American companies finally took notice.